This video will introduce us to the concept of equilibrium in chemistry. So dynamic in equilibrium means that many reactions are reversible. And dynamic equilibrium says that when the forward reaction is occurring at the same rate as the reverse reaction. And the way we represent a system at equilibrium is this double arrow here. So the double arrow symbolizes that. There are 4 criteria that have to be met for a system to be considered at equilibrium, and we'll explore those. So the first criterion is that the rate of the forward reaction must equal the rate of the reverse reaction. So if we take a look at rate over time, eventually those reaction rates would come and meet each other at equilibrium. So the rate of the forward reaction is equal to the rate of the reverse reaction. 2, the second criterion is that the concentrations of the reactants and products at equilibrium are constant. So if you were looking at the forward reaction, that would be the synthesis of hydrogen iodide, and the reverse reaction would be the decomposition of hydrogen iodide. So if we looked at the forward reaction, we would have over time more hydrogen iodide being produced, and we'd be consuming the products of hydrogen and iodine over time. And then if we looked at the reverse reaction, the same thing would happen. Over time, you would end up with less of the hydrogen iodide and more of the hydrogen and iodine. But if you took a look at the 2 graphs, they meet at the same place. So their forward and reverse reactions are the same, and the concentrations stay the same at that equilibrium state. The third criterion is that dynamic equilibrium has to occur in a closed system, so you can't have the entry or exit of products or reactants. It has to be a closed system, such as in a calorimeter, for instance. And the fourth criterion is that at equilibrium, there's no change in visible properties. So you wouldn't see a color change, you wouldn't have a change in pressure or pH or concentration at that dynamic equilibrium. So there's no change in visible properties. So there are a few different examples of equilibrium. There's solubility equilibrium. That would be when you have solid iodine dissolving to become liquid or aqueous iodine. Phase equilibrium would be solid water, so ice melting to become liquid water at 0 degrees Celsius. The rate of melting and freezing is the same at 0. Or you could take a look at the chemical reaction equilibrium, so the decomposition of calcium carbonate to calcium oxide and carbon dioxide. At equilibrium, you would have the same rate of forward and reverse reactions.